Tonight is August the 11th, 2016, and I've just got to show you guys one more video on this Acrosound amplifier. I am so pleased with it. I did put in 4 brand new 6SN7s made by Tungsol. It's got the 4 new KT66s by Tungsol. I'm really sold on these Tungsol tubes. And I changed it over from, from that, this schematic that I was building so much. I changed it over to this one that uses 2 6SN7s. This one and and here's the heath kit. They're virtually component for component the same thing. The heath kit W3M uses 2 6SN7s, a couple of KT66s, and here's the one out of the Acrosound. So if you build one, you've built them both. Now to tame this thing, on the left channel I had to add a 330 picofarad between the screen and the plate. And on the right channel I had to add a 500 picofarad between the screen and the plate, for the ones with the striped wires. And then I had to add one on the right channel, a 1700 picofarad off the ground. I used that General Radio variable capacitor to dial these things in. You won't believe how well this thing works. Okay, well, let's start. Left channel. There it is at 20 watts. That's all it's supposed to be rated at. It'll actually do 25 at these specs. But we'll just do it at 20. So we're not... See, there's our 20 kilohertz. 0.7% at 20 kilohertz. Let's see, right there, you should be able to see them both. There's 20 kilohertz. There's 2 kilohertz. See it, less than 0.2%. 200 hertz. See, the power is dropping an insignificant amount. And at 20 hertz. Look at that. 0.37%. Never changes from 20 watts. 20.49 at 20 hertz. .33 at 20 kilohertz. Let's go to the right channel. Let's switch our dummy load. Okay, we're at 20 kilohertz again. 20 watts. 0.8% THD. Always under 1%. 2 kilohertz. 0.26. 200 hertz. I do it at 2s because I don't have to, start tweaking the dial. 0.26% at 200 hertz and at 20 hertz. And again, like, notice the power just doesn't drop. 20 hertz over there. 0.4% THD. Amazing, isn't it? The little transformers are pretty darn good. Let's go back to 2 kilohertz just for the fun. And I'll increase the power. We'll kind of watch the THD until it gets to 1%. And I'll show you what we get here. Well, that's 1 1/4. Let's keep it right there. That's 1%. 25 watts at 2 kilohertz. It's hardly any worse than that. Let's go to 20 hertz. See, it's still doing 25 watts. THD went up a little bit at 25 watts, but the transformer is not rated at 25 watts. And at 20 kilohertz, still got almost our 25 watts there. And our THD is up at 2%. So it's very even end to end. But if we keep this thing down in the 20 watt range, even above it, to even 22 watts, it just does amazing. Both channels do the same thing. But I did have to tame it with those capacitors. Now, I know I had quite an event with that one transformer that I don't know if it was bad or not. I don't think bad's the right word. I guess it just had a lot of squirrely things about it. if you really go through and read a lot of these books, 1956, David Hafler talks about the capacitance, the anomalies in the transformer, and it's just all kind of complicated. And I guess these transformers are just not quite exactly all the same. This thing performs wonderful. Now let me turn the lights back on. I'll show you one other thing I did. As I started out with about 16 dB of feedback, and that was pretty good. That was like with a 15K resistor. But I ended up putting a pot in here, and if you can see where this one is adjusted, like where the slot is and where this one is, you can see they're the same. But you can also use this little bit of feedback, ever so slight bit of difference, to completely balance the output on them, and that's what I've done, so that I can operate these things exactly all the way up, and I can adjust for the slightest gain differences with the feedback. I don't know what the feedback is. I'm going to say it's about 20 to 21 dB negative feedback. The pot underneath it, the hum balance pot, just, you can tune it right in, especially by looking at the error signal down here. You could just make it completely go away. I thought it was important to show the changes, the difference in using the pair of 6SN7s in the Heathkit and Acrosound schematics. Made a world of difference. This thing sounds marvelous. I actually like the sound of it better in my Macintosh. 20 watts is plenty for me, and like I say, it actually does 25, but that's pushing it. I guess if it were on sale, I guess they would at least rate it at a 50 watt. They'd probably call it a 60 watt. If this transformer right here were a 300 milliamp instead of a 200 milliamp, it's actually a little small, and if I keep a little fan on it, it stays pretty cool. But if it had the right size transformer, and the perfect transformer for this would be the transformer out of an Dynaco ST70. Same voltage rating, and it is a 300 milliamp. But to change this out, it's a type that mounts with part of the core down under the chassis, and that happens to be where all of my filter capacitors are. So it takes some major surgery and reconstruction, so I don't think I'm going to go there. But I'm very, very pleased with this. So if you're going to build one of these and you're going to use these TO300, 305 type transformers, whatever, I certainly don't recommend that first schematic that I was building, but I do this one. It's really that good. Well, you see how good it is. I'm not going to bore you with lots of changes. This is at 23 watts, what I was running a while ago, and there's the two channels. See, 0.6% down there, just what you just saw, at 20 hertz, and about the same thing up there at 20 kilohertz. There's the two channels. The yellow channel is the right, and the blue channel is the left. The left channel always seems to be just ever so slightly better. I guess that transformer is ever so slightly better. It has just a few less kinks in it. But there it is, guys. I learned a lot from you guys and your suggestions, and I've done a lot of reading, and I just wouldn't quite give up. One good gentleman mentioned that I knew when to stop. Well, I think I know when to stop now. I don't think I can make it any better. Trying to squeeze another 2 or 3 watts out of it or something is not going to work. So there you go. You see right there, this THD and this these two numbers are displayed real time, or wherever it stops at 20 kilohertz. You can see it's 0.84. I'm driving it with 1.2 watts at 13.72 volts. 13.72 squared divided by 8 would be the power, and I assume, I don't know if that's I think that's the reading, 13.72. 13.72 squared 8 divide 23.5 watts. There's a lot of glare there, huh? 23.5 watts. That's what I set the reference at 1 kilohertz. So that's what those two our scans are run at. So you can see it does really good. Like I say, a good bit above 20 watts. I don't think there's anything else to show about it. I'm very pleased with it. Very pleased with these new 6SN7s, the Russian-made ones. I think it's beautiful. It sounds marvelous. Appreciate all the help and suggestions you guys have given me, and hope this helps others and encourages others to build your own vacuum tube amplifiers and have fun and be safe. Well, you should know I couldn't quite leave it there. And I'll tell you why. There are so many times when I have looked at schematics and amplifiers that other people have built, and they never show me all the details. And I want to know all the details. Okay, first of all, here's that hum balance pot. I'll show you how I can adjust that. I'm driving it pretty much full volume, 23 watts. Watch the arrow signal there. See, I get all fuzzy. Let's see, let's turn out the lights here. See, get fuzzy there. And fuzzy there. Wish I could turn the intensity down a little bit. You can barely see it. That'd probably help a lot. Yeah, see how fat this guy is right here? Well, if I get back in the pot, I can turn that until, see, it goes away. So I have balanced the hum, 60 hertz hum. Those capacitors I put in, one of them is right here, that's the 1700. This is a 1000, a 001 with a 680 underneath it. And then there's that 500 that I showed you in the schematic right there. And then there's that 330 over there that I dialed in with my that GR, this little jewel right there, that little GR capacitance, variable precision capacitor contraption. Now, as far as the feedback goes, what I found out, I need a little more light here, is I found out that with a 15K, I had about 16 dB of feedback, but I didn't have the minimum amount of distortion. So I went to the other extreme. The other extreme, according to some of the schematics, would be 1.2K times the square root of the impedance. So that'd be square root of 16 would be 4 times 1.2K would be 4,800 ohms. And some of the schematics actually even suggest a 4,800 ohm one. Well, that didn't work here. That caused this thing to motorboat. So I found out that close to the threshold of motorboating was a 5.6K. And then I put another 10K pot in series with it. That's what I was showing you from the other side. So if you adjust this thing all the way out so that it's fully, whatever that is, counterclockwise, I guess, then the only resistor, this would be the resistor in the feedback circuit. And same thing over here. There is some debate, and some of the older books say, there was a comment posted by a good gentleman that said that I believe Mr. Williamson said a parallel capacitor across this would not do any good. And you know what? I think he's right. I don't have one across it. It's been pretty darn good. Okay. Now in an idle condition, let's turn off the drive. So we have no drive. And let's look at the voltages. The B plus feeding the plate circuit is 437. So it's below my 450 volt ratings at my capacitors. Some voltages that are really nice to know about in case you start building these things are these voltages also, like right here. Well, two of them. there's 3 voltages in here. One of them is the plate voltage here. That's the 437. Another one would be right here. These no, right here, feeding these two 47Ks. Actually, no. See, they go back. These 47Ks go actually back to the plate voltage. So the 47Ks, these 47Ks right here, see, they come together right here, and they have oh well, wait a minute, I gotta do it the other way around now. They have 439 volts on them. 437, 439. Things like that are going to change momentarily, you know, a volt or two, you know, when your line voltage changes. So that's the same as the plate voltage. There's that. There's back on the plate voltage, 439. So we can't worry about 1 or 2 volts. Okay, the next point, so that's those 2 voltages there. The next points would be right here at these 22Ks, which would be right here, which is 310 or thereabouts. And then the next one would be right here on the other side, which is about 215. So these are some reasonable voltages to look at. Now, the way that I got these voltages is I put these value dropping resistors in there, 22K and a 33K, and I recorded the voltages. I don't have a 22K and a 33K there. I have a 10K and a 15K, because that's what gives me the correct voltages. These voltages of 215 and 310, that's what gives me the correct voltages running a stereo set of voltage amplifiers up here, this pair and that pair. You have to have both pairs in there to get the correct voltages. I have found out that I can pull out the output tubes and unload 100 milliamps off the power supply and get quite a bit more power out of it. But I do have to have these voltage amplifiers in, all 4 of them. Otherwise, I end up with too high a voltage on the voltage amplifiers and they perform really squirrely. Hope that makes sense what I just said. But anyway, those are the voltages that you would want. What I was just showing you. Here, and here, and here, and here. So those are the kinds of things that it's just so nice to compare to. Here's another thing I did. I had a piece of shielded wire from here, from this pot over to this tube. I took it off and put in a regular piece of wire. I ran it across the top so it wouldn't be running along under those filament wires. And then I taped it up to the underneath this lip right here with some aluminum tape. This piece of shielded wire right here, this is what I had in there. See this little piece right here? And it had an enormous amount of capacitance, I thought. Let me show you here. Zero this thing out. And if I can hook it up with one hand, it's about 75 picofarads or so. Yeah, there it is, see? 74.8, 75 picofarads. And I said, well, you know, who knows what that's doing on the input. Apparently not much. It wasn't harming things. I don't know what the capacitance of that little piece of wire is now. It's probably less than that, less than 75. But those are some other changes I made. I also I went to extreme lengths. I have to be really careful when this thing is on. I went to extreme lengths to do the very best I could in making this one physically, mechanically symmetrical with this one, and this one symmetrical with this one. The same binding post on each post, so that they're actually, you know, you can't tell them apart. Maybe it'll tell them a little bit apart now because I've moved things around, but they're not significantly different. They're as identical as I can get them. So I think those are the only other differences. And again, I point these out in case somebody else is building. It is so nice to compare are results of someone else's that has documented it carefully. Well, that's all I can think of right now. Oh, signal to noise. Signal to noise ratio, I can't do all this with one hand. I'm not going to do it. It's 77 dB now. And that's with an aluminum bottom on it. I'm actually going to put this aluminum bottom on it just to make it safe. It's got some holes over there. I think I might even drill some holes, like one right there, just to let some air, so that so some air can circulate through the bottom, so it can come in the bottom, you know, through this perforation here, and have at least one outlet for some heat to escape. I think I will do that as time permits. Here is the signal to noise ratio right there. 77.7. We'll round that to 78 dB. That's not the best in the world, but it certainly isn't the worst. The other day I was toying with it and it seemed like I could put my hand over this. It's not too hot, and it would get worse, but right now it doesn't seem to be changing. As a matter of fact, it seems to almost get better when I put my hand over it. I can't explain that. I know that, let me show you something that changes signal to noise ratio enormously. This little fan right here. Watch when I turn this thing on. Well, I'll be dang. A while ago it went down to like 59 dB or something, you know, it just went to hell on me. I tell you, it's tough when you can't duplicate anything. It kicks you around and then you try to duplicate it and it goes like, nah, I'm not going to do it now. Well, anyway, a while ago when I turned this fan on, it just all went to hell. So I had to move the fan away. I don't understand that. Anyway, there it is. In a state being not driven, no input, and the controls all the way down, doesn't seem to matter if they're all the way down or all the way up, but they're all the way down at the moment. Turn them all the way up. Here's my 60 hertz hum, about minus 85. 120 hertz is minus 95. The third harmonic of 60 is out here. That doesn't matter. But anyway, there's our 120 hertz and there's our 60 hertz. So they're down at minus 85 and minus 95. You know, some comments were made on an article I read today about back in the day when the 3580A, the Hewlett-Packard 3580A was the king of the hill. You couldn't even see these things back in those days. And if you couldn't see them on that, well, it must be good. And I agree. So I never malign the old equipment. I love it. Just absolutely love it. But the point being is, if you were looking for these signals on the old HP 3580A, they would not be there. And you would say, hey, this is good. Or if you did see this one at all at minus 85, it would be the tiniest little blip you can imagine. And you'd say, well, that's pretty insignificant, isn't it? We've done a marvelous job. Well, now we want it even less, don't we? Do the best we can. So things change pretty rapidly, or at least they have, from what I can have today and what we had 35, 40 years ago.